going to talk about the measures of central tendency because this is really one of this is a really important part to um, moving forward and getting the work done and starting to analyze things statistically. Um, we've been doing things in starting to build our knowledge and understanding, right? So far, we understand what the variables are, we understand what frequency distribution tables are, we have an understanding of these things, right? So now what we're doing is we're going to be working with the measures of central tendency, which helps us understand our data a little bit more. Now, with this, understanding the measures of central tendency is important. We can use it for our visuals, of course, but really it's most important because it allows us to summarize our data. It allows us to summarize our data and be able to have a better understanding of what's happening, the story it's telling, the picture that it's painting, right? And so from there, we're able to work with larger data sets and more variables. So the idea of multivariate data is important because we might need to summarize more. We might need to summarize things that have more than just one variable. In this case, multivariate means two or more variables. So multi being multiple, and then the variates, right, being variables. So being able to understand the measures of central tendency and how that influences our movement forward is important. So in terms of the measures of central tendency, there's a couple words that your book uses and just kind of acts as if you should understand what they are. And one is distribution. It's used it a lot, and we're going to continue using that word. And with distribution, it's essentially how things are distributed, right? So how it's spread, how it's broken up across variables and values. So like it's the similarities and differences. So we're looking at how things are spread out, how values are spread out across categories and variables. For the measures of central tendency, what we're looking at is basically the average or the typical, what's average or typical about the distribution. So thinking about central tendency, right? Central, where is that kind of middle point, and tendency, what does it tend to do, right? That averages or typical patterns or trends that are happening with the data. It's essentially looking at categories and scores and then being able to describe these things. What is typical across these values? So there's three concepts that we're going to talk about: mode, median, and mean. Each of these serve a different purpose, but they still highlight typical distributions of values. So they all have a different purpose, but they still allow us to see the measures of central tendency, the distribution of values within a category. So in chapter 4 on page 100, it talks about range. It's a little bit of a jump ahead, but at the same time, it's important, I think, that we talk briefly about what range is. So the range is basically just that. It's the range of values. What that means is that it's what is the distance between your lowest and highest value. So if you had like points, for instance, 4, 6, 19, 32, 79, those were points. Your range would be 75 because 79 minus 4, right? 79 is your highest value, 4 is your lowest value. You'll also see these little curly brackets, and those are called curly brackets, and they basically mean discrete values, and that's where you'll see your range. The discrete value is basically our values that cannot be subdivided, right? So go back to continuous and discrete from a couple weeks ago, and that's what we're looking at with our range. And the reason why I bring up range now is because how can we understand, what what the data does, what it tends to do, where the center point is, if we don't understand kind of what the range is. So the next thing that we're going to talk about is the mode. The mode is the category or the score with the largest frequency. This does not mean it's if you had like a rating scale, it does not mean that 10 is your mode simply because it's the highest number. It's the value or the category that has the highest number of things that are occurring. It's the easiest to identify. So it's essentially the answer or the selection that somebody chose, or that the most amount of people chose. You find the category and you find the highest frequency. It's really the easiest to identify. It's the thing that occurs the most amount of times. it's the category or the score, not the frequency itself. So if it occurred 17 times, you're not saying the mode is 17. You're saying the mode is whatever category or score or value is there. If you have something that has more than, you have like two categories that have the same, are the highest though, what's called bimodal. So think about bi being two, modal for the modes. If they're also close but not exact, so like let's say 75 and then 74.8, that is essentially still bimodal, and you would report those two you would still report the two highest categories or scores. Now, the next slide we're going to see from your book it should be on page 64, an example of how mode can look. So in this case, they listed as foreign languages, but I'm referring to it as languages outside of languages in the United States that are not English. And so this is like the number of speakers on the right and the language on the left. And this is the number of speakers in those corresponding languages. In this case, Spanish is the mode. Now, it may not be organized this way though, and it's important that you understand and identify how you will be able to organize your data as well, because you're going to have to organize it. It's best to organize it to be able to see what the mode is. In this case, it's easy to identify, right? We know what the mode is. The mode here then is Spanish. Spanish is the mode because it has the highest number of speakers. Now the median is different. So the mode is relatively simple because you can identify it. Remember, it's not the frequency. So in this case, it's not 37 million. That's not the mode. The mode is Spanish. In this case, the median is different because you're going to want to put things in order. There is some sort of logical order. Not everything will fit into here, but you can still find the median in the vast majority of things. But it's the exact middle of the distribution or the spread of numbers. So in this case, it divides it in half above and half below. So you have to sort your data. You have to sort it from, highest to lowest or lowest to highest. If it has the even number of cases, you divide it in half and you do the calculation based off of those. If it has an odd number of cases, you use this formula n plus 1 divided by 2, where you divide it in half, and that is your value. And I'm going to show you on the next couple of slides so it makes a little more sense. So essentially, though, the median is where you have your data, and it's half above, half below, and the median is literally that middle point of the data. So in your book, this is the table that it presents to you. If you look at it, right, the number of hate crimes on the left is not in order. It is not in any order. It's just randomly placed there. Now, if you look on the right, it has the state and its corresponding state with the number of hate crimes that occur in it. So we see that there are 9 cases, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 cases, 9 states in this case then, that have reported the number of hate crimes. Now, we've reorganized it now. We've ordered it. So if you look, right, there's no organization. Now we've ordered it from fewest to greatest, from least to greatest in terms of amount. So now we can see that this is in some sort of order. Still 9 cases though. Now, if you look at this here on the left-hand side, this is 9 cases. So because it's odd, we have to use this little formula. So we have 9 cases right here. There's 9 cases plus 1 because we need to be able to figure out the middle, divided by 2. So in this case, we get 10 divided by 2, which is 5. So what it means is that we need to look at the 5th case. So 1, 2, 3, 4, 5, which gives us Texas right here. And that means that 145 is our median. That means that Texas here gives us our median of 145. So that means half the number of cases will be fewer than 145 and half the number of cases will be more than 145. So that's what the median means, is the middle point. Now, this is for our odd number of cases, but what happens if we have an even number of cases? So we know that our median is 145 here. According to, like, your textbook did this, so let's say for a minute California didn't report. We have 8, so we still have this order. We've taken California off, so we're pretending it doesn't exist right now, and we have 8 number of cases. 1, 2, 3, 4, 5, 6, 7, 8, right? So what happens is you look at the 2 middle. So 1, 2, 3, 4, 1, 2, 3, 4, So that gives us North Carolina and Texas. Well, what you have to do is you have to add these 2 together right here and divide it by 2. So it gives you your median, and your median is 142.5. So the median basically means that there are going to be half the amount of cases that are above 142.5 and half that are below. And this is if you have an even number of cases. You find the 2 middle ones, you add them together and divide them in 2 to get you your median number. and I'm going to end this video here, and I'm going to create another video so that way you have them divided into two. Okay, so we're going to go ahead and leave off now from where the last video was. And the last video we were talking about median. Now you have your frequency distribution tables, and those are useful when we're trying to figure out our median, right? Because you've already kind of organized all the data. But what happens is when you are creating this, sometimes you have certain categories that are associated with it. So we kind of already talked about that a little bit. And essentially, when there's some sort of category, though, that isn't numerical in value, or is like a different category in terms of what you're trying to measure. So on page 70, it talks about political views. It says that the mean, well, not the mean, sorry, the number comes to 721.5. So that's the median. In this case, it's not saying that your median is 721.5. What it's saying is that value is associated with the label of moderate in political views, and that's what you're going to go to. So in a couple slides, I'll talk about it a little bit more, in more detail, but that's just something to think about when it comes to calculations of median for these categories. Another thing about this is, percentiles. So you've probably encountered and experienced percentiles. A lot of standardized testing has percentiles. And with these percentiles, it gives you an idea. So a percentile is not the same as a percentage. It is a general location within the range. It's a score at or below a specific range. So if you scored in the 75th percentile, it means that 75% of cases are below it. And that's a typo, so I apologize, but 75% of the cases are below it. So that means that 25% of the cases are above that. And it doesn't mean you scored a 75%. You could have scored a 20%, but you still are 75 in the 75th percentile. Or you could have scored 100%, but you're still in the maybe the 75th percentile because there was extra credit stuff. So these are things to consider when we're talking about the calculations of the median. So we'll talk about percentiles in more detail at a later point. So now with that is our mean now. And this calculation, or this formula here, is super important. When I refer to these things, this Y here stands for Y bar. This E is sigma, which means sum. The Y, so the combination of these two is the sum of all your scores, your variable scores. Y bar means your mean. And this N is the total number of cases. And this is the formula that you use to calculate mean. There's a couple different ways that you're going to calculate data values. It's mostly for interval ratio variables, but it's anything that has a data value to it. And we're going to talk about this in more. You might also hear it referred to as average. Okay, so we're going to talk about that in more detail on the next couple of slides to see how it's applied. Depending on what type of data we're using, that data informs how we move forward with it. So we're going to go to the next slide. And, oh, too far. Okay, so this is on page 73. It's in chapter 3. And this is about the ideal number of children. So essentially, this is a survey about the ideal number of children. And that means that they were asked, what do you believe is the ideal number of children? So the list here is, 0, 1, 2, 3, 4, 5, 6 with the number of children. And frequency is the number of responses that selected that option. So in this case, these were the options: 0 children, 1 child, 2 children, 3 children, 4, 5, 6. And this is the number of people who selected these options. So 13 people said 0, 16 people said 1, 506 said 2, etc., which gives us our N at 868. So if you look over at this, excuse me, I'm going to move this. So if you look over at this here is sigma times sigma is the sum of your frequency times your y value. So your frequency times your y value, in this case, is frequency times your y value. The reason you're doing it this way is because you're trying to measure the average number of children, all right, that it seems to be ideal. So in this case, you have 0, you have 16, you have 1012, because what you're doing is you're multiplying your y value with your frequency. So this is 506 times 2 is here. So this gives you your n of 868, and then it gives you your sum of all your y's, which is 2139. So what you do, if you go back to that formula, is you have 2139 divided by 868, which comes to 2.46. And so so in this case, right, that means the ideal number of children is 2.46. We'll talk about how we can report on this, or the different ways that we can report on this, but ultimately it's totally cool to say 2.46 children. And go from there. So what we do is we're making this calculation, and you're trying to figure out what the answer is. So in this case, again, the ideal number of children is 2.46. All right. Now, here's a couple things to think about in terms of calculating mean in a variety of other ways. So when we're looking at means, this one's a little more straightforward in some ways. Not this. All right. So, well, okay. So before, this was a little more straightforward in terms of the calculations, but sometimes what happens is we have to actually assign a numerical value to something. So when you're using a linear scale or a Likert scale, generally you're, if, or let's say you have like a value, a number value, you've already assigned a numerical value to it, but sometimes you don't. And so you'll just have strongly agree, neither disagree, etc. And you'll assign a numerical value to it if you haven't already. Now, this is then, if you have your frequency, this is the number of times that somebody selected this option. Then your frequency, same thing. And this is what it comes to. The way you analyze this and you interpret it, though, is your mean comes to 2.25. You don't have a 2.25 over here. That doesn't have any value or any meaning to us, right? So what happens is you identify which numerical value closely aligns to the 2.25, which basically is this neither agree or disagree. So this means that most people are, the average comes to 2.25, which aligns with neither agree or disagree. So that's essentially how you're identifying that, how you're using the mean in these types of linear or Likert scale calculations. Now, there we go. Okay, so, okay. So sometimes you're going to have grouped things too, right? Or frequency ranges. And so for a lot of you use things like hours works or credits. And so similarly, like on the left side, hours worked 0, 1 through 5, 6 through 10, 11 through 15, 16 through 20. You assign a numerical value to that as well, because again, you're not calculating this per se on its own. You assign a numerical value. And the reason this is also a good practice is because if you were to do a quantitative reasoning class where you have to actually do some additional statistical analysis, being able to understand how you assign a numerical value to it is important. So then you create a frequency, or you include your frequency. So in this case, we have this, it comes to 32. And similar to before, sorry for having to move this, similar to before, you have the same process, right? So it's 0, 3, 10, 24, 16, and then this comes to 53. So, darn it. Okay, so in this case, your mean is 166. Now, this is kind of where it's tricky because it's kind of arbitrary, which means there's no real rule for it. So the way I would say is like you figure, okay, well, the numerical value is 1.66. It's kind of divided here. Well, which really kind of leans more towards 6.10, but it also means we're not completely there. So really you could say that most students work within the range of 1.5 per week, but they probably work a little bit more than that range because that's essentially what it's telling you, right? Based off of this mean. So that's how you would calculate some sort of grouped frequencies or ranges that you have here. Now, I realized that with the nominal data, I was thinking about it in terms of your individual questions. And I had worked with most of you, and you had like grouped frequencies and ranges. You had a variety of other things. And so I wanted to kind of clarify a couple things that I may have said. So nominal data itself can't be calculated with a mean. Some of you may actually have when I say nominal data, I don't necessarily mean um, mm, I don't necessarily mean it in terms of like hours worked and such. I mean nominal data specifically in terms of like gender and eye color, and even major. And so you're not going to have a mean calculation in the same way. You will have the percentage breakdown, which is calculated similar to the mean, but it's not the mean in the typical way. And the reason I say this is that you will assign a value to them, so similar to like the previous slides, and that gives you insight to be able to run things statistically. But it's not a mean in the sense that it shows you a point of the average use of something, or average water, or average hours. So if I said that you would have a mean for everything, the vast majority of things will have a mean. Some things will only have a mode if it's only a category. So sometimes your data, if it's ordinal data, you will have it. And for a lot of your projects, most of you have like interval, ratio, or ordinal. But thinking about some of the major ones, like major, that is nominal, and that's not good. It doesn't have any order. So you can calculate these averages, right? But they don't have a statistical meaning in the same way. And so I just wanted to make sure I cleared that up if there was any confusion about what I was saying. Which is why for some of you, when I said to have these, I perhaps the better way I should have said is like have it set up to where you will have 2 rows, 2 columns, and you can calculate those things in terms of that breakdown. So some of your frequency distribution tables will be enough for that, but essentially in this case, you can calculate percentages, which is essentially very similar, and that was my confusion based off of the number of projects that I've been working on closely with all of you. So I just wanted to kind of clear that up. But it is important when we're talking about some of the 2-column ones that I was asking you to do, which will arise in terms of your project. So for instance, you're thinking, let's say you want to know, you have been talking to these 5 people, Sam, Charlie, Sarah, Max, and Joe, and you want to know what the average or mean number of miles driven in a year between these people are. So you ask them, how many miles have you driven in this past year? And they give you this variety of things. So Sam gives you 7,335, Charlie's 36,295, Sarah's 21,523, Max is 10,235, and Joe's 12,567. So in order to come up with your mean, it's going to be very similar to where you calculate all of those numbers. And you divide it by the number of cases. So in this case, you add these all up, comes to 87,955. You divide it by the total number of people, which is 5, which means that your mean miles driven is 17,591. And that's it. That's all you have to do for this mean or average calculation. So really the big thing is to think about like nominal, because there's no order to eye color. There's no order to any of those things. But if you had like a category that was ordinal in terms of like stress levels or a variety of those things, then that's where you would calculate the mean. You will calculate percentages, which are still kind of like averages in a way, but you're not assigning some sort of hierarchical value or statistical value to it in the sense that it will inform or influence some sort of central point. And so that's kind of what I wanted to clear up and clarify here. So that's all there is for measures of central tendency. So you are going to be thinking about these things as you move forward.